Good afternoon, colleagues, and welcome to our second presentation on photogrammetry. Tonight we have, well, it's evening for Singano, it's afternoon for Dr. Michel. This evening we have Dr. Michel with us, who's going to be guiding us through his presentation. There's an introduction. I think Dr. Michel will put it up here about himself. So without further ado, I would like Dr. Michel to present his work.
Thank you, everybody, for inviting me to your work today. Today I will share from my experience in the area of the field of photogrammetry. This is where I spend 20 plus years, 25 plus years in studying and researching and working. And I still have humble experience, and I don't think I know everything. I'm still learning as we go, but I'll share from what I learned from the past and things I see coming up in the future in photogrammetry. My name is Michael Morgan, or Michel or Mitchell. Call me any of those, it's fine. Background about myself, I did study civil engineering, and I did study geomatics engineering in variety of names, geoinformatics, geodetic science, and they come under different names. And I went to a variety of institutes in Cairo University, in Holland, Ohio State, in the States, and Canada here. So I've acquired lots of academic backgrounds from a variety of places. I'm a professional engineer, and I'm also a certified pilot here in Canada. I am a reviewer for some photogrammetric journals, so I review some of the papers before they are published. As I mentioned, I have 25 plus years of experience in industry and research and academia as well, teaching too. Currently, I teach at SAIT in Calgary, Alberta, Canada. The agenda for today, I'll be talking about photogrammetry, and apologize if you already know what it is. I'll try to be giving the presentation for somebody that doesn't know what photogrammetry is. I'll talk about back in the day, the way I remember things. I'm not that old, but I do remember using some old stuff, and I just try to point out to these techniques and older technologies, if you will. Then I'll talk about the evolution, how things progressed as I see it, and as I saw along the last 25, maybe 30 years, from the introduction of the digital systems, GNSS, IMUs, automating processes or making even processes autonomous, affordability of the hardware, then jumping into the drones, and looking into some of the traditional and the new products in that area. And things that are really that you hear about, and sometimes people associate them to different disciplines, but they actually really tied to photogrammetry. I want to put a spotlight on some of these, like augmented reality, autonomous positioning, because photogrammetry plays a very important role in there. Some people don't actually get the link or don't make the connection. Feel free to interrupt me at any point during the presentation and ask your questions. I'll be glad to answer and continue on, or wait till the end. Is up to you. Photogrammetry, it's in plain English, it's the reverse of photography. So while photography is about taking photographs about something depicted in this picture, object, ground, if you will, and a photo or a camera taking a photo about the object. So photography going this direction. So from an object, you get an image. Photogrammetry is the opposite of that. You have a picture, you want to find out about your object or object space, and you work in the other way around according to this arrow. This works in actually, let's see photography first. It's going, the arrow is going this way from the object to the image, image 1, image 2, or as many images as you have in your project. Photogrammetry is given different directions to the arrows, and from points or features in image 1, image 2, you try to connect the dots. This point similar to this point, and you connect the dots, put an arrow going this way, and here you try to reconstruct the object space. It is a surveying, it's a high precision work, and it's it can get very accurate, as close as possible to field surveying work. It wouldn't be really as to the millimeter accuracy as you do with maybe a total station, but we'll get closer, maybe closer to GNSS accuracy. So it is an airborne, they call it aerial survey, photogrammetry or aerial survey, the surveying from airplanes. Usually photogrammetry is done in blocks, and you wouldn't just capture 2 photos, you capture many photos and you arrange in a specific pattern. You plan for your project execution going on a specific direction. You collect several photos and you turn around, collect another strip of photos, and you mosaic them, collect all of these photos and tie them and process them somehow. That actually never changed. It's still the same between back then and now. But back in the day, things were done like this is an old picture of an old camera. It's an airborne camera, and you would take it, mount it on an airplane, collect photos. The plane flies, and you get the photos and you process them. Back in the day, things were film-based, not digital, and you would take the photos, you develop them in a dark room, and you would print them. They were black and white first, but then they made the color ones. And at the end, once you have a printed ones, you call them positives or diapositives. You put them on a plotter like this one, and you manually orient the photos. You try to view them in a stereo viewing capabilities, these instruments. You identify things, you digitize things on these photos, whether you're doing some sort of interior orientation, relative orientation, or absolute, and lots of stuff done here manually in this whole process back in the day. Later, things changed. So scanners came on. So people still use these cameras, still existed for many, many years, it's still in operation right now. But people now don't take the printed version, they scan them. So scanners came and changed your photos from a printed version into a digital version, rows and columns, and that actually made things go a little bit faster. And computers, after computers were introduced, that's like maybe even before I was born, and some of the analytical functions were done based on computers, not based on manual operations. So these operations, introduction of scanners and introduction of adding more computing power, this really added to speeding up that. But still, majority of things that were happening in photogrammetry were done manually up to this point. Several researchers 20, 30, maybe 40 years ago start to look into ways to improve on the processes and automate some of these processes and introduce automatic matching procedures. I do recall several famous methods by Forstner, Moravec, Harris, and a few more that they try to using the digital image and try to find what is in common between photo 1 and photo 2, and finding the corresponding conjugate points or features, and they use these approaches. They had a good success, but it wasn't really that autonomous. So they tried to do a good automation. Maybe they reached 50%, a little bit more, but they didn't reach a good stage to boost that field of photogrammetry. And I do remember working on trying to identify even or use different type of feature other than points, linear features and polygons and few other things, try to get things more robust. But there were a limited success in all of these operations back in the days. Then GPS came, and GPS was there for even longer time, but they started to put GPS on the planes, and that helped in two things. Actually, it tried to reduce, or it helped reducing the requirements of control. And the other thing actually helped with making the automatic matching procedures more robust. It didn't go really to a full autonomous fashion yet, but at least based on approximate locations or reasonable locations of your plane at the times of the exposure, some software packages are able to tell where possibly be the conjugate points when you do automatic matching. That the whole idea is about finding corresponding points or features in variety of images. Then came IMU. IMU actually exists in variety of grades. This one is the one that you have it on in your cell phone or a drone. These they can vary from $10 to hundreds of thousands of dollars. And introducing these to an airborne system, they also introduce them to the drones. Drones will have these as well, but the ones on commercial systems, they are of higher grade. And putting both GPS and IMU on a plane or a sensor mounted on a plane, that actually dramatically reduce the requirement of control. Some companies claim that they don't need ground control anymore, and they'll just stick to what they have. They still worry about some datum effects and offsets, and they still use control as a check. But some people tell me that they really don't need control anymore as far as they have good GPS, good IMU on board. The ones on the drone are of lower grade, but still can do the job. Then came the digital cameras. So digital cameras existing a long time ago. I attended the Congress, the IASPRS Congress in year 2000. And that's when many companies came on board, Leica and few other companies came and said, we have now a new airborne digital systems. Before that, digital cameras existed in the market. You can buy it in the store, but finally they made something that can be put on an aeroplane, expensive systems, and claim to be robust. They were good ones, but that only helped in the reducing the wait time. So that actually, prior to having a full digital solution, airborne digital solution, before that we had the film base. So that the time we would spend in developing the film and creating these positives or printing those and scanning those, that is the only time that actually was saved. Be honest, that didn't actually make a huge impact on the industry. The other one that I found is very interesting, the ADS, these airborne systems that they can actually lead to seamless or a very long strips. That's the only addition that I see that is of a great advantage to all of these airborne digital sensors. Not until recently, around maybe the year 2003, 2004, and when computer vision, people working in the computer vision area, they came up with approaches that would really push the photogrammetry or expose photogrammetry to everyone because of the robustness of these algorithms. Something you hear about like SIFT, scale invariant feature transform, structure for motion, a few more. These came recently in the 2000 plus. I remember SIFT was done by a professor in David Lowe in University of British Columbia, and gained huge popularity because it made things more robust. And not until then, when things started to go into the autonomous, and instead of just the automatic procedure where you need to go and do lots of manual editing to matching and stuff, things start to get more into the autonomous way. And after that, things started to pick up speed in the photogrammetry. Then the drone came. Now we have the drones, and they have all of the sensors that we talked about, the cameras, the GPS, IMU, they're all existing in a drone. These get cheaper. As far as these got cheaper, then became more affordable to people to acquire, to use, to play and to research with, to perform projects with. And it gained a huge attention last maybe 15 years or so. And also what added to that, not just because of the cost of these hardware got cheaper, but also the algorithm that were developed in the computer vision area that actually made processing of the photos that you get from the phones efficient. And you don't need to wait long time or maybe do any manual processes. You just need to get software to do the work for you. Same sensors, if you will, that you see in a drone, they exist on your smartphone. If you have a smartphone, you will have a camera in it, you will have a GPS, you will have IMU, whatever you have on a drone, you will have it on a cell phone. So basically, whatever you collect with the drone, you process it, and you get some geomatics products, digital elevation models, and point cloud. You can do the same thing with a phone. You can even build your own system. If you don't like the ones that pre-built, you build your own system, and you can build your own drone. You can build your own collection. So this is one of the systems that I've built, and I've been using this for research purposes, putting a camera, putting an IMU, a GPS, even a LiDAR. I can put a LiDAR and I connect them through, plug them into a Raspberry Pi, and I start collecting my data. I can't fly that though, but if I will, so I built my own drone. But because of the affordability of all of these sensors, things actually pushed photogrammetry to get exposed to the public. Mainly the drones. The drone is the one that really everybody talks about and give photogrammetry the spotlight. For the drones, before you fly a drone, you need to be aware of the regulations in the country where you operate it. So in Canada, this is actually a link from Guyana, from your country. And if you want to get a permit, and I'm sure you know how to do that, I copied these from your website, but there are lots of things are similar to what you have, comparing to what we have here in Canada. You have to get a permit, and you have to make an application. You have to specify the dates and times of your flight, and create a map or a sketch for your area of interest. You need to tell if you using a standard drone or you customize a drone. If you put stuff on the drone that you're lifting things not supposed to be lifting, you have to get approval from the authorities for that. The purpose, are you doing this for fun, or are you doing this for work? So all of that you will have to provide before they allow you or grant you the permit to fly the drone. So you need to know what you can and can't do and get the proper permit to do so. Insurance is a big one, and I do think the regulations here in Canada forgot to put the insurance at some point. When I took the exams a few years ago to becoming a drone pilot, I didn't see anything related to insurance. Maybe they added it now, but anyways, regardless, I always make sure that I have the insurance that covers the liability in case I crash into something. So it's important to have that. Even if the regulations even doesn't say it, you will have to, it's good to have a liability insurance make sure that things are covered in case of accidents. And things happened. You cannot ensure that the process is 100% proof. Things that I see that is common between regulations in variety of countries, maintaining visual line of sight, and this is existing in Canada, and I see it also existing in your country. Keeping the visual line of sight, so making sure that you can see the drone all the times. That's important, so you know it's not going to hit something, whether something that is flying, an aircraft or a building, for example. Maintaining setbacks, whether you need to know where you're flying, how high you fly. Are you allowed to fly above certain height, or there's always a window of flying height where you can fly between this and that. So that's kind of a setback or allowed window of flying in terms of elevations. Setbacks horizontally, how far you are from roads, from water bodies, and other properties, and that's something also you need to research and study before you even fly your drone. Make sure you abide by the rules and the regulations. And of course, you're flying over an area of land, need to have the owner's permission. So you don't just fly in any random spots. You make sure you have a permission from the owner, and it's a good idea to have a written permission, always to keep your documents handy with you when you fly your drones. But the regulations cover a lot more than that. This is just a snippet I copied from the regulation that I found on that website. But the majority of regulations will be similar from country to another. There are several types of drones. The one I use the most are these multi-rotor quadcopters. Majority are done by DJI, but so many other companies make these drones. The other one that is also popular, I haven't used it, but I believe the city of Calgary has some of these ones as well. The fixed wing. The fixed wing is just keep flying on a straight line, and you turn around. You make a bigger circle when you turn around, and it needs a launch pad, or you just throw it in the air. It has to have it has to maintain a speed to keep flying, while these can hover. These can hover in the air. Each has its own applications, and some this can cover larger area, can go higher speed. This maybe cover smaller area and can go slower. So depending on the applications, you choose a type of drone that works for you. There are also the RTK drones, and RTK drones, they're good because you can get a sub-centimeter accuracy when you're talking about RTK, and I believe most of you have a surveying background and you use GPS. When I say GPS, I mean GNSS. You have a base, you have a rover. The rover being now the drone, the GNSS instrument on the drone. It collects corrections from the base and will adjust the location of the drone. If you give it a specific path to go and to follow, it will try to follow that path. And every photo will get it's going to be tagged with the proper coordinates. So that will be like a few centimeter accuracy. IMU, it did not improve actually quite a bit. I should say IMU still the cheap $10 IMU. Still they put it on the drones. I don't know if they put a expensive IMU. IMU is it's a driving cost of the big airborne systems, the commercial ones. Maybe in the future the price is going to go down. They're going to put higher grade IMU on the drones, but to my knowledge, it's not there yet. When you plan for a flight, and I put this picture here to demonstrate this kind of sketch showing a forested area, and if that is me, and that is a helper, a visual observer coming with me on the job, and we'll try to make sure we see the drone when flying it. If I fly the drone here, that would be a bad choice, because the drone flying this way and I see it all the time till it hits this point, then I don't see it anymore. And going through this area is really a hazy zone. You don't want to fly there. You might hit a tree, you might hit a building, you might hit a wire, anything. So that would not be a safe flying height for a drone. So flight planning is crucially important. But if you fly it higher here, in a way that you will see it all the times, you or your assistant in the field will see it, then that will be a safe flying height. But make sure this height is under the permitted height when it comes to the regulations. So always check the regulations when you plan for a mission. A part of that, the launching the drone itself is a straightforward, and nowadays you just use an app with your fingertips. Say, I want to fly this area, delineate the area, and say how high you want to fly it. And you want to fly horizontally and vertically in a grid. You choose a pattern, you choose the overlap between the photos, and launch. But before that, you have to do a little bit of calculations, and you need to know the resolution, what you're trying to achieve. You always keep a picture like this handy, the flying height, the focal length of your camera, the pixel size, and you do a little bit math to determine the GSD, or ground sampling distance, the pixel size, how much each pixel covers on the ground once you fly it at specific height. Some of these apps, they give you the GSD right away, some they don't. And then you adjust and make sure you do the math right. And when you go and fly over the site, the data is going to be useful. You don't want to waste 1 day of work. You have to calibrate a drone before you fly it. And that is me at SAIT, and with some of my students, were taking a drone into a flight. And I mean that the process of calibration or calibrating the drone is really straightforward. There are lots of videos available on YouTube, and just pointed out 2 of them. The model I use is here is the Phantom 4 Pro, and each drone got its own way of calibration. This one I had to calibrate the IMU first. That's done in a stationary fashion, and calibrate the compass as well. Compass is what tells you about the direction. It is like the sensor that points to the north, the compass. It's important for the drone to know its orientation with respect to the north, and compass actually will help the IMU. Both together, they adjust each other, because the IMU it drifts over time. This is a cheap IMU that they put on a drone, and to make sure it doesn't drift that far, they put the compass to rebalance the IMU. But both sensors will have to be calibrated in a specific way in the field before you fly. And there are lots of techniques by which you can do this calibration. Now, taking the data, you fly your drone, the process after that becomes almost autonomous in a way that you don't need to manage it. It is the drone is going to fly to a specific flying height, and will do this pattern, then come back. But you gotta keep an eye on it all the times, make sure it doesn't hit something. And although some of these drones have sensors to detect obstacles, sometimes they fail, and you don't want to risk that, though you always keep an eye on it. Although most of the process is done for you, and you just keep an eye, and once it lands, take the data, download it, and I would take the data to a software to process it. And thanks to the computer vision methods I talked about, a software like Pix4D is one of the software packages that I use to process the data. It makes processing the data way easy. I really don't need to do much. When I load my photos I took from the drone, I'll just import their, I think that I didn't have any picture of the initial process. You load your photos, and you say, if you have a control, you have control points, you load your control and just to guide the software where the control are, and then click to start and wait till it's done. Really, is not much to do in there. And the SIFT algorithm, structure from motion, all of these things, and they keep updating, keep improving on the autonomous computer vision processes. This will help get this done from A to Z, and you just watch. Early in the day, this wouldn't be done this way. You would be, if you do conventional photogrammetry all times, you would just go and run the APM, automatic matching procedures, and you do lots of editing. Relative orientation wouldn't come nicely because of the bad matches and mismatches. Now things coming almost autonomously here. And that what drive actually the field of photogrammetry and the field of drones. And people take drones and fly them and get data. They don't want to do any manual work. They just want to get the data with 1 click, 2 clicks, done. And that's mainly, I do this in a software called Pix4D, but there are lots of software that do the same thing. And I listed some of them, and some of these packages actually are free. Pix4D you pay for, but some of these are also paid software, but some are free. Mushroom is one of the very sophisticated pieces that will handle drone data, and you don't need to pay for it. Some are open source. You can even check the source code for that. So the cost actually is going down, and if you look for free stuff, you can always find free stuff to do the same quality of work. Some of the sample products, so things that I often get when I process data, I create digital aviation models or DMs, digital surface models, orthophotos, point clouds. These are the typical things that you get from a software. But you take it to the next level. Some people take point cloud and create volumes. Some people create 3D models after that. I'll see if I have the computer there, if I can log into that computer. No, somebody's using that computer, so I'll stick to the video that I pre-recorded here. Some of the projects that I went and collected data and processed them up to the point of creating digital elevation models and point cloud. I didn't show many of these byproducts. Let me get to that link. This is one of the missions that majority of these I done with my students, by the way. We went to field and collected photos, and this is actually this is an orthophoto that came directly from after processing the drone data, and the quality and the resolution and of the data is amazing. You can see the cracks in the pavement. That's one of the sites we surveyed and see the car. The car actually was moving, as you see here. It looked like a ghost here because from one photo to the next it moved. But if it was stationary, you can even get the car done. You can get a point cloud and point hitting the cars all around the cars, and you can reconstruct that if you want to. But that is a site that I flew one day with my students, and that is an orthophoto created automatically. I almost need to do nothing by processing this into the software, just downloading the data, click start, maybe add some control points, and done. And that's just a picture of the orthophoto, and that's before maybe a Google background image or Google Map image. You see the differences. Just a couple of sites here. Maybe nothing interesting here, but students when trying to do more of flood analysis and finding where would the water go if there is a rain or a snow melt, and the owner of the land needed to know that. But I'm actually here in this picture. This is where we were taking the drone and taking off here. That's me somewhere here. I don't remember it's Middle or that guy. I'm one of them who's flying the drone at this mission. But it's a high resolution data, depending on, of course, the flying height that you choose for this job. Before and after, and one of the sites that I went was students again, and they wanted to model this building in 3D, and I tried to zoom in to see how much detail I can see, and that trailer that is parking on the ground, if you zoom in, you can almost see the writing on that trailer. That's how good the resolution is. And if you want more resolution, you fly lower, but just make sure you're flying at a safe height above the ground. I want to see the next one. I have a few here. This is a site where we wanted to model the slope. Want to see the slope stabilities along the river banks, one of the rivers in Alberta. And I don't know, I was interested. I didn't go to this site. My students went, and I was interested to know what vehicles they were driving, and I can point to the vehicle. I can find my students around here. They were moving around. It seems like ghosts in this orthophoto, but all of this created out of the drone data. Then I start to see, what do I have here in my photo? I can see the details, the rocks, and going to the river banks and the river, and that was frozen at that time. We'll see the ice on the river. Yeah, that is a picture, background picture. It's you see it came from maybe collected in a summer or another season, but when we went to the site, went in a winter, that's why I see differences in the water surface. Maybe I'll speed up and go maybe to the 3D, or that's one of the sites that it was up for development. One of the areas in Calgary, the city wanted to redevelop this area, and they were trying to see who are the people occupying the area, and they asked us to go and survey it. So we really didn't want to touch the ground, and because of some issues with the people that occupying the area. So we flew the drone and we collected data about the site. We got all information the government was looking for that site. But we have a very high resolution here, even though we were flying like 70 meters above the ground. We wanted just not to disturb the people that are in that area. I'm going to move into some of the point clouds. These are all orthophotos, standard photogrammetric products that you would do in typical photogrammetry, and it's just is done by the software. I really didn't need to do much in there. The other byproduct that we get here is a point cloud. Let me try to get to. Another site, a student needed to calculate volumes. Company asked us to calculate volumes on stockpile, and we went, and this is a 3D of the point cloud that we created out of the drone data. We actually done this twice. We've done this based on a drone data, and we've done it based on a cell phone data. So believe it or not, students went, took the phones and walked around the site, and they tried to take the photos with the GPS, with IMU that were on the phone, and together they mosaic them, collected, blended them in a software, and able to also create a point cloud. But this one you see here is based off the drone data. that stockpile. This is one of the sites that has trees and play area. This is one of the fields that people do some games in that area, and we're asked to fly and acquire data over that site. Actually, I'm amazed by the quality of the point cloud that you get out of a software like this, thanks to the computer vision advancements, because matching points on trees is the hardest thing ever, and you still get a reasonable amount of point data or features extracted automatically without doing much work on trees and very difficult features, without almost like having a LiDAR, although you don't have LiDAR, it's only pictures, and you're doing photogrammetry, the conventional photogrammetry, but from a new perspective, and getting all of these millions of points, and you use them for any purpose. One site here, this site that was up for development, and I also was amazed by the point cloud, the quality of the point cloud that you would get even on a power line. So that's a power line, and I would always think that we can't do good or proper image matching on a point on a power line. But believe it or not, the techniques that are used behind the scenes in these newer software packages will allow you, or will pick even those points on a thin object like a power line. So that's huge. Before, you only can get this from a LiDAR, a dense LiDAR, so you don't miss this power line, but now you can get it even with the drone data. And this is a site near the river, and seeing the point cloud is all point cloud here, but each point comes with the color, and that's why you see almost like a picture. And so many projects here. I'm not gonna go through them all. Try to skim through quickly. This is done by a cell phone only, and whatever you have in a drone, you have it in a cell phone. And there are parts, like if I go back to one of the sites here, that we try to collect the data for buildings. These houses, owner wanted us to get the 3D models for these buildings. There are lots of information on the roof because you're flying with a drone, but what about the side of the building? If the drone doesn't see it, you don't get data. But this can be done with a cell phone. Basically, they really complement each other. And this last part here is done with a cell phone. You have a camera on your cell phone, you have a GPS IMU, you can also create point cloud with your cell phone on a building like this. So that's actually something that many people don't know that exists. We can get that. Can you get this with a cell phone? Yes, you can. It's photogrammetry, stitching the photos together and do automatic matching using the recent techniques, and get a point cloud anywhere you want to go. And the last piece here, this is a famous rock. I always take my students there and take a photo around this rock, and we blend them together. And at the end, everybody would be very excited to see a point cloud, few maybe tens of thousands of points just make up this rock. And they do this job in just about 5 minutes. That's a 5-minute job. And I always say, if you do this with a laser scanner, how long it takes you to do this with a laser scanner? Probably a couple of hours, and you have to set up a couple of spots. So that is actually what you can do with these sensors, whether it's on a drone, whether on a cell phone, and really the sky's the limit on as far as you have cameras and you have GPS IMU, you can do a lot more. My experience or my expertise really not taking it beyond that, but some people go to levels and levels of processing and create some cool stuff. I limit myself to these three, and sometimes volume, sometimes 3D, but the applications of drones are really limitless. If you go here, you'll find people use it for all kind of applications, from surveying, of course, from inspections. Agriculture is a big field, using drone for control and also for monitoring, rescue and emergency, marine, mining. Yeah, mining, actually, you can use drones in mining. And I will show you one example shortly, something I've done, not with a drone, but can be done with a drone. We're going to get to this in a minute. But so many people using drone for a variety of purposes. And the sky is really the limit and what you can do with these. Want to shed light on a couple of some of the applications that really people tend to forget that there is actually a photogrammetry behind them. One of them is the augmented reality. And this is one of the apps that I built with my students to see, to mix something that is unreal with the reality. So having a design and trying to blend that design into the reality on a phone in this example. So going into that video. So I took the phone, I built a model, and I put the model here somewhere, and I start to look for the model and turn the phone around till I finally found it. That object doesn't exist, but that could be a design. Somebody want to design a building here or a bridge or something, and want to see how this looks like once it's put in place. That's called augmented reality. You mix the a design with a reality, and you can walk around it. I went closer to it, and I maybe turned the phone. Things turning was the ground. So the legs, if legs are sticking to the ground, you're going to still stick to the ground, even if you rotate the whole thing. That is actually photogrammetry. The base concept and the math behind that is all photogrammetry. One of the cool areas that I happen to work on. The other one is, I found this also interesting, and I've been doing this for a year or a couple of years now. Let's see that video first, and then we'll comment on what that is. So what I have here, I took some photos. I went through a tunnel. I took some photos, and just walking you through these photos somewhere in Calgary here. I can tell you I took this with a drone. That could be the case, but I took that with a phone. They both could work the same way. I can still fly the drone and take the same pictures and process them the same way. So I took pictures all the way through the tunnel. And again, my device has a camera, has GPS, has IMU, and I collected all that information. Then I left the tunnel. At the end, I went a couple of more meters and done. I went to the office, took the data, processed them. Even before processing the data, I just wanted to see my GPS log. So I loaded my GPS log here in Google Earth, and I found that GPS was not that good inside the tunnel, and you know that. And I was going almost a straight line. GPS told me, no, I drifted, you know, the multipath and also problems that you see inside a tunnel, lots of signal and few other problems. So really, GPS failed me into the tunnel. So what I did, I took the data and I processed them into photogrammetry software, in this case, Pix4D, and ran all the checks and got my data displayed. And at the end, what I was able to recover is this gray line, this made of these dots. That is the recovered path. And that is actually the actual path I went through. It's clamped to the ground here because of Google Earth, not because of the poor processing. No, that the elevation has an elevation as well. It's under the tunnel. The tunnel here, the elevation is obtained correctly. This is just showing where it is planimetric in a planimetric view. GPS failed me, but fusing all of this in photogrammetry, I was able to recover my actual path inside a tunnel. And showing this into a different perspective. This is a Pix4D software where I used to the software I used to process the data, and I can see the actual path is the green one, while the blue one is a GPS. GPS was really off, totally off, but the green one is a corrected path, and I can go from one image to the next through the tunnel. And guess what this does? And this actually is a basis of autonomous driving. And if I don't know, like what companies use, mainly Tesla. If Tesla is based off vision, using vision to determine locations, they also use GPS. But there are instances where you lose GPS signals, and especially driving in a city, and you want to know where you are from surrounding objects and vehicles. Vision is the one that is used here in this process, and that's what companies like Tesla and the like use to determine your precise positioning and how close you are from your other objects in your environment. So really, the base of this is photogrammetry. Vision is another way to say photogrammetry, but in the computer vision world. So really, if I go back to my slides, I lost my slides here. Autonomous driving, self-driving cars, some of them, some are used LiDAR technology, some are using pictures, like Tesla. They depend a lot on what you do here in photogrammetry. There are so many applications, but these are the ones I really touched on myself, and I played an experiment and research on. Really, the sky is the limit. Watch a presentation by a company called Skyview, and they take the drones to different levels. And the drone, as we use it, or as I use it, I use it to collect the data from below and or front, or I try to capture something to map later, create a map and also photo point cloud, or do any cool 3D modeling stuff after. But what this company does is actually they use other cameras on the drone to detect their environment, same as I showed you in my tunnel example. They use that and get the drone to be able to determine the safe places to go and the unsafe places to go. And you can take the drone autonomously now into structures. You can go between beams and steel structures and complicated environment that I would not dare to fly a drone manually in these areas. I would simply crash them. But because they depend on additional sensors on the drones, some of the presentation I attended, they say they have many cameras in different parts or areas of the drones. They look in different ways, and they use the vision. They do automatic matching and all of this cool stuff, and try to determine where the drone is with respect to the environment. Same as a tunnel example, but maybe a lot more than that. And they use this to train the drone and to go to places autonomously. So really, that is one of the interesting application. The photogrammetry is used twice here. One to map things, one to derive the whole vehicle. So that will just conclude the remarks here to my presentation. Photogrammetry, as I see it, and I'm not that old to see it from the early stages of photogrammetry, but I watch some of the parts, the old stuff in photogrammetry, and I see how things evolved over time, and it'll continue to evolve. It's not going to stop there. And thanks to the drone actually put a spotlight on photogrammetry, made photogrammetry popular. And what drone used, or the data that I always bring in, get from drones and process, that's photogrammetry. So they both really help each other quite a bit, and give each other a boost. There are lots of technologies. I just highlighted a couple of them, but so many technologies nowadays as far as use cameras, LiDAR, and few more sensors. They really use photogrammetry in the background. Even they don't use the word photogrammetry quite a lot. Photogrammetry maybe tends to be more of an ancient word. People associated always with some manual work, but really it's way beyond that. Photogrammetry is the new reality, the future, the automation on autonomous processes. So that concludes my presentation. Thank you for your patience, and welcome to take any questions.
Dr. Morgan, just if you could just review your chat, you will see a few questions being posted there while you were, can you pull that up?
Let me see here. I'll try to see that.
If you'd like, I could read them out to you, and so that you could just.
Okay, might be easier. It might be easier. I'm having a hard time using Zoom. It's not familiar with the Zoom. I use Teams a lot. So yeah, if you can just let me know what type of questions I have. Oh, okay. Actually, I got to.
Oh, you got it. Yes.
I got some of them. Okay. Explain the difference between DM and DSM. Okay, so DM is they call it also DTM if you coming from Europe, and I studied a little bit in Europe, and they call that DTM. DTM and DM, they mean the same thing. They are really talking about the natural terrain or the bare earth before you actually think that you put a building or a tree. So if you think about any environment, if you strip out the trees and the buildings, what is left is a digital elevation model, the bare earth. And DSM, or digital surface model, is the surface, as you see it from the top, that goes on top of trees, and down back, if you have no features, back to the earth again. But when you see a building, the surface is gonna be covering the tops of buildings. Naturally, with any photogrammetry data, mainly photo-based data, what you get is a DSM, because the photo doesn't penetrate the buildings and doesn't penetrate the trees. So originally, what you get from photo-based data or photogrammetry, you get the DSM, the surface. And there are lots of methods to do some sort of filtering, to filter out the building, filter out the trees, and you're going to be left with the bare earth or digital elevation model. If you're using LiDAR, it's a different technology. LiDAR penetrates the trees. It doesn't penetrate buildings though, but penetrates trees. And you, based on that, you can tell which points are on the bare earth, which points are on the tops of the trees, and you can distinguish between the digital elevation model and digital surface model in these treed and forested areas. Buildings areas, you will still have to do some sort of filtering based on LiDAR. Does it answer the question?
I think it certainly does. The next one that came up was, have you compared the accuracy of point cloud with RTK drone with the normal GPS drone? Example, P4 RTK versus Phantom 4 Pro.
I have not actually, I've not owned an RTK drone. I do think that accuracy will will improve. Whatever you get from an RTK on a ground, even regardless of a drone, it's the same thing. You're gonna get it from an RTK drone. Like if you do ground surveying with RTK versus single point positioning. Single point positioning, if you don't have a base, then you're off by what? A couple of meters. If you have a base with an RTK, go to a centimeter level. Same thing with a drone. You get to the centimeter level. I have not done the comparison myself, but I don't know if anybody did, can speak up.
We do see a response from a Daniel. I don't recognize this Daniel, and he has given a few. Yeah.
Oh, Daniel Roda. Hi, Daniel. Hi, Daniel.
Daniel is well known by Michael, Morgan, and Kamal.
Oh, so. Hi, Daniel. Good to see you. I didn't know you're here. I should be careful when I speak since you're in the audience.
Oh, your presentation was great, and
I hope
our answers are similar. I just don't remember if the Phantom drones have dual frequency GPS on board, so RTK corrections would help the centimeter level if it's dual frequency, but if it's just single frequency, it won't help as much. So I don't remember that specific detail.
Actually, Daniel, just to let you know, most of the ones with GPS RTK are actually the Reach M2 is the popular one that is on most of the Phantom 4 Pro.
Mm.
So they can get RTK corrections uploaded. Yeah.
Okay, great. Yeah, and then say if you're doing the point matching in Pix 4D, then the main help is that your photo's initial position is in the much more accurate, say, a few centimeters off instead of potentially a few meters off. So your point matching is more likely to succeed, especially if you have weird repeating patterns on a building or trees and all sorts of things that are hard to find a distinct point match. And if you have IMU angles, that helps even more.
Yeah, that's actually a very good point. And however, IMU, as you know, it's not going to be perfect. And that is the one actually that will not let you really get away without control on the ground. And because of the IMU, it's far from perfect. So the RTK is great and get to the centimeter accuracy as Daniel and Kamal mentioned. But because of the angles aren't perfect, unless you have a very strong block geometry, you could get away with some of the IMU problems and processor data. But I do still recommend that always, even with commercial systems, bigger ones, and always control is recommended, let alone drones. I would definitely use control with drones.
All right,
Yep,
thank you guys.
All right.
That was...
I got a few comments to make on that topic question. Actually, I raised the question. Now, what I was trying to get at, so you have a Phantom 4 RTK drone. Obviously, when you're using that drone, your photos will be accurately known as they're being taken by the drone, right? Within centimeter level, each photo will be known. The position will be known.
Yeah.
Right. So you develop your point cloud from that. Your point cloud would be good. It would be perfect. Now, if we use a drone with a regular GPS without the RTK functionality, right? You find that your photos now will be off maybe 1.5 meter or 2 meters. Each photo that is being taken
Correct.
would probably be 1 to 1.5 meters off. Or
And
maybe
that
2
will
meters off.
and that
Correct.
will vary during the flight. It'll sometimes be,
Right.
say, 1.5 meters to the left, 2 meters to the right, then it'll be on.
That's
and
right.
It kind of, yeah.
That's right. That's right. Now, the question I want to know is, if we do, obviously absolute positioning will be off. If we should develop point clouds from the RTK data and from the regular drone, data from the regular drone, how would that compare? Would there be a huge difference in terms of accuracy of point cloud because of the photos being maybe two meters off? Does the question really I wanted to get at?
So without an RTK, and if let's say, assuming you don't use any control in any of these approaches, so that if every photo is off by 2 meters, worst case scenario that this 2 meter is consistent and it's one direction, and everything going to be shifted by these 2 meters. So the quality of your point cloud is going to be off by 2 meters. But relatively speaking, together all the points, if the software does the proper process or process the data properly, I should say, then relative orientation will be fixed, but the absolute will not be fixed. So the whole thing going to be need to be shifted by these 2 meters. While if you do this with RTK drone and the accuracy of each photo is about a couple of centimeters, then your final product's off by these few centimeters. If you're the non-RTK drone, if these errors, as Daniel mentioned, these errors aren't consistent, aren't in the same direction, may actually help if 2 meters going this way, the other photo 2 meters going that way. If they have some random effect, they might help each other to get to a better accuracy, but it won't be as good as the RTK ones. That is considering that the only error budget is actually in the GPS, but don't forget there are angles, and the IMU on board is always bad. I can't say it's a cheap one. The IMU on the drone is a $10 chip, and you can't get much from that. So if you have a positional error in the plane location or the photo location, yeah, will translate to positional error on the ground. But if you have an angular error by 1 degree and you're flying maybe 50 meters above the ground, and the nadir won't be nadir anymore, will be off by 1 degree, see how far that will cause on the ground. So be aware of the IMU errors. Everybody talks about the RTK, but people tend to ignore the IMU because it actually can cause a bigger problem, not just a GPS. GPS can cause a minor problem. You get a 2 meter off in the GPS, 2 meter off on the ground, 1 centimeter off on the drone, 1 centimeter off on the ground. But IMU, no, the effect will really propagate from the plane to the ground because of the long distance. However, having said that, coupling a couple of photos together will help fixing some of the issues of the IMU, but not all of them.
Yeah, that's bang on. And if you have a nice photo block with flight lines going back and forth with nice side lap, it'll be much more forgiving. But say if you have a corridor, say along a pipeline or a power line only flying once, that will be much less forgiving in the point matching if there's an offset.
Absolutely right. The corridor is worst thing to only depend on IMU. I never do that. Yeah. it's gonna roll around and the whole thing gonna really get out of control very easily. So always keep in mind to have control or even checkpoints for the drone work.
Right, Dr. Morgan, I just wanted to confirm that having ground control points would mitigate these problems. Yes?
Of course, of course.
Yeah.
Of course.
Absolutely. Yeah.
Even if you don't have any GPS on the
Yeah.
drone, any GPS, once
Actually-
you have ground control points, you're able
Absolutely.
to have.
Yeah, absolutely. Yeah.
Good.
In the older times, like that I mentioned 30 years ago, they didn't have GPS on planes and or IMU, and they did the whole thing was only ground control on the ground. We call this indirect orientation process, where from the control you can estimate where the plane was at that time, and yeah, control is good enough, and you need to have control even if you don't have on board the GPS or IMU.
Excellent. All right, I had a question. How do you specify the orientation when using your cell phone? But I believe Daniel answered that you use an app, a separate app.
I actually, for that process I showed you, I built an app that it does nothing, but it takes a photo and creates a log file. So each photo will have the coordinates, the latitude, longitude, and height, plus the roll, pitch, and yaw for every photo. So it is, I did it based on an Android system. I had to go and look up the device specs and see how I can extract that information from the device. And I was create this and dump it into a text file or a log file. And that's what I use to feed into software, and the software will process the data. Again, if I depend only on the GPS inside the tunnel, and as I showed you, it's really going out of control. But putting the GPS and IMU together, in addition, actually IMU wasn't the driving force inside my tunnel because it's a cheap one, but it was both the IMU and the autonomous matching between the photos while I was going through the tunnel. That drove the precise position I was going through there.
So I guess what I'm trying to ask, would it still be possible to calculate volumes and do proper orthomaps, or not even orthomaps, 3D models, using the normal cell phone, like an Android Samsung or something? Or do we need the orientation?
Actually, without orientation, even without a GPS on your phone, if you're just taking simple photos with your phone and you process them, you do the automatic matching between them, and you establish some sort of control, and you identify this control in these photos, yeah, you can get point clouds, and you can create calculate volumes and do 3D modeling and anything else. Yeah, you can do it without GPS, you can do it without IMU. Just as simple photos can work. The GPS and IMU will help speed up the process. That is the only caveat here.
All right. Evans and McKenzie, is there a site where these data are stored and where they can be accessed for educational purposes? He's speaking as a lecturer.
I'll have to check about that. I'm not 100% sure if I can share it publicly, but I'll have to ask if I'm allowed to do that.
Right, Allison, these recordings, we will post them up on YouTube, and we already have permission from Dr. Morgan. Okay. I have another question. When putting together your own rig, that is a camera on a drone, how should one go about calculating the offset between the GPS and that camera? How should one do that?
You're talking about the offset between the GPS on the drone and the camera on the drone, that offset?
Correct.
Okay, I don't know if software the companies like DJI and all of these will use this into the put this into the picture and calculate this offset. Traditionally, this offset has to be calibrated, measured, calibrated through lots of testing and stuff. And I can't tell whether the companies actually incorporate that offset or not, or assume because you're flying far away from the objects, then the offset compared to the distance to the object is actually can be neglected. So I can't tell whether they model that or not, but theoretically, yeah, it should be modeled. Same as the misalignment, the angles between the IMU and the camera. The camera has its own coordinate system. The IMU has its own coordinate system. They're not perfectly aligned. The X, Y, Z for each system isn't perfectly aligned with the other. So that also need to be calibrated. How far companies like DJI went along this route, I don't know, but they may assume that almost the same, and that things will be absorbed by the subsequent processes.
Well, you did mention that you're able to put together your own drone and build it. So that's what I, it's based on
No, I did not.
Yeah.
You can build your own drone. Yes, you can if you know a little bit of hardware, and you can buy simple pieces, chips, and connect them together. You can build your own drone. I did not build my own drone. I built my own system that is made of Raspberry Pi and few sensors. Here actually. Actually, it's a little bit further this way. Yeah, this one. I built a system like this where I had a Raspberry Pi and have a camera and I have an IMU. Am I still sharing my screen?
Yes, yes.
Okay. And I have a LiDAR as well. I put the LiDAR on top. So LiDAR, GPS, IMU inside. A camera here on this side, and have a screen to monitor what's happening. So I built that system. I took it apart now because I need to reuse it for something else. But you can build it. In my build, I had to model. I had to model the offset between the GPS and the camera, and also the orientation. Orientation was hard. Like this offset, you can measure it between the GPS and the camera. You can model that. But the angles between the IMU and the camera is very hard to do it. You have to calibrate the system to do this job. If you know a little bit about electronics and you're willing to take it further, you can put some propellers on top. You can fly the system. You build your own drone. You can do that. But I built something just for testing and research purposes only here.
Morgan, can I jump in here? In the classical aircraft system that has a camera and a GPS, that offset, Daniel, correct me if I'm wrong, you can use bore sighting software, to determine that delta offset between the camera and the GPS antenna, of course, and the misalignment of the IMU. But it's not something you will get from DJI. You'll have to fly a test block and you will have to calibrate it. And then you can, specialized software like from Novotel, Inertial Explorer, you can determine that bore sight value, which is the delta XYZ. And if the IMU is of good caliber, you can determine the delta omega phi kappa also.
Yep, that's those are all right. So yeah, usually, when you're putting together a system like this, you would measure the distances in X, Y, Z of the GPS antenna. Usually there's a measurement point near the bottom, and then depending on how professional grade the antenna is, it'll tell you, there's like a phase center inside the antenna, so it'll give you some millimeters to that. That you can usually survey in. And then for the IMU, you would just need to know how the axes of the IMU line up to the axes of the camera. So maybe there's whatever a 90-degree rotation this over X and Y or something like that. And then exactly then you use the data itself to do the really fine alignment bore sight angles. And if you have say a tactical grade IMU, like one that has really fine angles, then that's a process worthwhile doing. If it's like a smartphone level IMU where every time you use the smartphone it'll give you different results, then it might not be, though that bore sight might not be worth doing. So it probably is depends on how good of an IMU is in the system.
Yep.
Yeah, makes sense. And I think that is maybe the approach that DJI and similar companies are doing. I don't think they bother by doing this calibrating the offset and the misalignment, that the minor misalignment, not the 90 degrees to map the axes properly, but they do map the axes, and they know how to align X with X from two different systems, Y with Y, Z with Z. But is the minor the few minutes offset, as Kamal mentioned, traditionally these are done in a test flight and calibrated based on a site with control. But whether these companies, because these are the whole system is cheap, like drone is a cheap system with each piece by itself is a cheap piece, and is it worth doing this big calibration or not? It's a question to these companies. I don't know if they do it or not, but
yeah. And so say on the drone level, you would probably just do an aerial triangulation or Pix4D point matching for your entire data set every time, while the bore sight is more for, professional aerial survey companies in an aircraft where their goal is to cover huge areas and they want to try to not need to do a full aerial triangulation on everything all the time. So on the drones, typically you'd always do a triangulation every single time with all your data, and a bore sight would just not make sense unless you have a very high-end drone like the US military or something like that.
Yeah.
All right,
Dr. Morgan. Yeah, Dr. Morgan, can you comment on the importance of the camera angle, right? When doing surveying work.
Yeah. So the camera angle is one parameter that you would decide on it depending what you want to get out of the ground. So if you're looking at the rooftops and you want to get the roofs, and you're just looking straight down with whatever, like roll pitch angles would be zeros. Heading, depending where you're driving the drone, north, south, east, west, but roll pitch will be zeros. If you're interested, and depending on the application, you want to see the sides of the building, then you turn the camera to that direction, and that's mainly done through either the direction or let the software determine this direction automatically, so the camera will turn in the flight to point to the sides of the building, if that is your object of interest. If you don't, and then you still need that data, you either fly again and turn your cameras, or go with a cell phone, and now you're turning your cell phone towards the side of the building. If you're interested in that, you're making a roll angle of 90 degrees to face the building. From a drone, you turn it maybe 45 degrees to get the side of the building. I don't know if I answered the question, but you turn it the way you want, depending on what you want to map at the end.
Yeah, and I like to imagine a pyramid where the airplane is at the top of the point of the pyramid, and then the bottom is the frame of the picture, and those orientation angles give you, essentially how that pyramid is crooked from perfect straight down. And then you have that information. it allows the triangulation to be much more accurate right off the bat, less likely to misalign when it's trying to point match and stuff like that. So like say in a drone, it'll never be perfectly pointing straight down. So lots of times that pyramid is crooked or your terrain isn't flat and stuff like that.
Yeah, absolutely.
Thanks a lot, guys.
Yeah, no problem. And then lots of times if you don't have that IMU angles, we would assume the camera's pointing straight down, and then we use the change in position to approximate your heading. And then you can kind of use that as a, you know, initial angles. That's better than nothing.
And
I
the
think
point cloud, yeah.
Yeah. Oh, sorry. I was just gonna say,
Yeah.
and I think Pix4D has some settings where you can, it automatically assumes that for you.
Yep, it
Yeah,
does.
it does. It does take Pix4D does take those orientations, but I never really input data without header that telling the software about coordinates and angles. So I don't know what it assumes, but it probably does to put an approximations to these photos. And but again, all of these will update whether you have a good IMU or bad IMU or no IMU. The orientation will be estimated for you after software does do the automatic matching and find the relative orientation between one photo and the next.
Mm-hmm.
I think we have a couple of students in the group. Students, you can ask questions if you wish to.
If not, and you have questions, Dr. Morgan, would it be possible that before we post this on our page, we send your questions by email, and maybe if you were able to respond, would that be something
Sure, yeah.
that's possible?
Yeah, I can do that. I can respond to the questions by emails. Yeah, absolutely.
All right. Thank you so much, folks. I'll hand over to our president, Lou, who will do our vote of thanks.
Thanks, Donald. On behalf of GAPS, we would like to thank you, Dr. Morgan, for taking time out to come and share your expertise with us. The presentation was well received. You touched on a lot of very important topics and provided us with much needed information. We're very grateful for it. Thanks a lot to you, and Daniel also chipped in and provided some vital information for us. So thanks to him also. So once again, thank you guys.
Thank you for inviting me today.